All right, this is a video for the remaining problems from section 5.4 that we skipped over today in class. We're going to look at how to do each problem in great detail so that you will not only be prepared for your quiz on Tuesday, but the final on Thursday, and just knowing what to do for your homework as well. So we kind of touched on a little bit of everything we needed to know from this section, but I want to make sure that we are good on all of the ones that we skipped over. So this very first one here, it says change to logarithmic form. So what we learned was that, excuse me, exponential and logarithmic forms are just two different ways of writing the same information. So we did A and C in class, so let's convert B and D right now. So when you're going from log to exponent form, you think of converting it to the form log blank blank equals blank. The base, which is the part attached to the exponent over here, is going to be the base of the log, which we write as a subscript. The exponent is the answer to a log, so it goes on the other side, and then the remaining piece is now the argument of the log. So that is the correct format for changing 3 to the negative 4 equal to 1 over 81 into log form. So this one would be log base 7, because that's the base that's connected to the x. The x would go on the other side, and then the argument is 100. Now, if we know how to enter this in on our calculator, which is what we're going to focus in on Tuesday, we would be able to solve this then for an approximation of x. So this is a very helpful and useful tool to be able to convert back and forth. Okay, let's look at example 2. It says change to exponential form. My technique for this is to use the spiral technique. I did A and D in class, so let's do B and C really quick. So we have log 4 of 1 over 243 equals negative 5. So if you're in log form and you want to go to exponential, you can do this by spiral. You grab the base, you raise it to the exponent, which is on the other side, so 4 to the negative 5th equals the argument, which would be 1 over 243. And you don't have to have the parentheses, but I'm just keeping it the way it is. So 4 to the negative 5 equals 1 over 243. And then we would want to do this one. This would be v to the q equals w. So pretty simple as long as you know how to do the conversions. I told you not to focus too much on the properties, that most of them can be solved just by doing the spiral technique as well. Then we talked about how to graph logarithms and how logarithms are the inverses of exponential functions, which means since our exponentials had range issues, in other words, not the whole real number line could be the range, that means that our logs will have domain issues. So the log's argument must always be greater than 0. It cannot equal 0. It cannot be less than 0. The range of a log is everything on the number line. It's negative infinity to infinity. And then the vertical asymptote is whatever sets the argument of the log equal to 0. So in other words, it's going to be tied into kind of the domain. So we learned that, and there was 3 methods you could use to graph. I honestly prefer just converting them to exponentials and then making a table where you pick the y's and you find the x's. Seems to work for most students instead of trying to flip-flop back and forth between the inverses and stuff. So we need to look at a couple more of these. So let's start with part B. So for B, we can rewrite this as y equals log 3 of negative x. The first thing you want to make sure before you do the spiral to convert this to an exponential is to make sure that this log is isolated over here on the right side. There's nothing added or subtracted at the end. There's nothing multiplied at the beginning. So as long as that's true, we can go ahead and convert. So this would be 3 to the y equals negative x. Now typically when I go to do my table, I like my x to be solved since I'm going to be plugging in y's and finding x's. So this is actually negative 3 to the y equals x. So when we go to do a table for that, we're going to pick, and since there's nothing going on with the y is just a y with no adding or subtracting after it in the exponent. If I don't see anything weird like that, I go ahead and just do negative 2 to 2 in my table, just like we did when we were doing exponentials, but now we are picking the y's. So this would be negative 3 to the negative 2. Remember, the negative is out front, so this is really 1 over 3 squared and then a negative in front of it, so negative 1/9. And you can use your calculator to evaluate some of these. This would be negative 1/3. Negative 3 to the 0 would be negative 1. Negative 3 to the first would just be negative 3. And negative 3 squared would be negative 9. So we would plot negative 9 to, I'm just going to work my way from the bottom up, and -3, 1, -1, 0, -1/3, so that's not quite, it's not crossing this, it's over here. So -1/3, -1, and -1/9, -2. So notice this still has the vertical asymptote of x equals 0. This log has just been flipped across the y-axis, which makes sense. It has a negative inside of its argument. Anytime we saw a negative in front of an x inside the parent function, it made it reflect across the y-axis. So that is what this log looks like. Okay, we did C in class, so I'm going to focus on D. So f of x equals log base 3 of x and then -2. Notice the -2 is after the log. So before you can do your spiraling, which is what we like to do to convert this to exponential, you have to move that -2 over to the other side. You want the log to be isolated. Okay, so then we can spiral. This would be 3 to a binomial. So 3 to the y plus 2 equals x. Now, when you go to make a chart for this, because there's a +2 up there with that y, we are going to offset our table by what would make that equal 0. So y plus 2 equals 0, we need to start with -2. So -2 is going to be the middle of my y chart. So then something smaller, we could use -3 and -4. For bigger, we could use -1 and 0. So this would be 3 to the -4 plus 2. So that would be 3 to the -2. So that's going to be 1/9. No, this time there's no negative in front, so it's going to be positive. 3 to the -3 plus 2 would be 3 to the -1, so that's going to be 1/3. And then 3 to the -2 plus 2 is 3 to the 0, so that is going to be just 1, and this will be 3 and 9. So you're noticing a pattern kind of emerges here. So this is 1/9 down -4, and this is 1/3 down -3, 1 down to -2, 3, -1, and 9, 0. So notice, if you have something added or subtracted at the end of the log function, oh, that's a horrible picture, by the way, you still get your vertical asymptote at x equals 0. The only time a vertical asymptote can shift is like the one we did in class, when you have a horizontal shift. That would shift a vertical asymptote. So for us, this is just shifting the whole picture down too. All right, let's look at E. So this is y equals I like to put -1 times log 3 of x. So this should be a reflection because we have a negative in front of our parent function. To make this work, I'm going to go ahead and get the log isolated, so I'm going to move the negative over by dividing it. So now I have a -y on this side. Then I'll do my spiral to convert it to an exponential form. Makes it easier for graphing. So 3 to the -y equals x, and my x is isolated, so I'm ready to do my table. So this would be, and it's just a -y, so it doesn't matter if we do -2 to 2. There's no plus or minus anything in that exponent. So we'll start with 0 in the middle, and we'll just see how this works out. So 3 to the -2, that's actually going to be 3 squared, so that's going to be 9. 3 to the -1, that's going to be 3 to the first, so that's 3. This will be 1 because it's to the 0 power. So this is going to reverse. This will be 1/3 and 1/9. You kind of see a pattern once you've done these enough. So 9, -2, 3, -1, 1, 0, 1/3, 1, and 1/9, 2. So notice this log has been flipped upside down, which makes sense because of the negative in front. So essentially, the big thing here with doing these is first write it as y equals, make sure the log is all by itself on that side, so you might have to move some things over. Use the spiraling technique to turn it into an exponential, and then before I do my table, I always make sure x is isolated before I go and start plugging stuff into the table for y. We did a part from example 4 in class, so I'm going to do the rest of these. I believe there are 4 of them. This is how do you solve some log equations. There's 2 essential types of log equations. So the ones that we've encountered are as follows. If you have a log with the same base on each side, it has to be a single log, same base, one on each side, then their arguments are equal to each other. So that's how you solve those. If you have a log on one side and a non-log on the other, you can't set x equal to y. That does not work. In this case, you have to convert to be able to solve. So b to the y equals x. So that's essentially the two different ways that we can solve logs, and it depends on what they look like on whether or not which we choose method 1 or method 2. So b is obviously a method 1. We have log base 7, one on each side, so we set the x minus 5 equal to the 6x. To solve this, you would subtract over the x, so that's going to make that 5x, and we would divide by 1, so this, or 5. This would make that negative 1. But the problem here is that your arguments have to be checked. Okay, so x minus 5 has to stay greater than 0, and 6x has to stay greater than 0. If either one of these fails, it's done. The solution does not work. And in fact, this one fails in both cases. Negative 6 is not greater than 0. So even though we found a solution, there is actually no solution that works. Because when you plug back into a log equation, the answer you get has to make sense in the argument. It has to make this stay within its restricted domains. So we cannot use negative 1 as a solution. For this one, this is a part 2, because notice there's no log on the right side. So this would be 2 to the 4th equals x minus 5. So 2 to the 4th equals x minus 5. So 2 to the 4th we would work out. That's 16 equals x minus 5. Add the 5 over, this would be 21. So before I circle that, I need to check it. The only argument you have in this case is an x minus 5. So is 21 minus 5 greater than 0? Yes. So as long as that argument checks out, the solution is good. All right, and then let's look at D. This again has one log on one side but not on the other, so we need to do our spiral technique. So 4 to the negative 3/2 equals x. We need to remember what to do with this. I would convert this into being on the bottom first, and then I would turn this into a radical. So this is 1 over the square root of 4, and then it needs to be cubed. So that would be 1 over 2 cubed. So I'm getting that this should be 1/8. Checking our argument. Our only argument here is an x. That's the only thing we have inside of any log. And 1/8 is definitely greater than 0, so we're good there. So this is our solution for this one. So just being careful that you get all the correct answers and the way you set up the solution. How do you set up the solving process? So checking your answers for log equations is really important, and other than that, just making sure you set it up the correct way. If there's a log on each side and they have the same base, you set their insides equal. If there's a log on one side and a not log on the other side, you're going to have to spiral. So that's it for the section 5.4 notes. Make sure that you review as much as you can for your practice quiz. And I will be posting, I'm going to try to post a 5.5.5.6 pre-video kind of thing where a lot of the examples are already worked out if you want to get ahead. I know not everybody wants to learn new material the day before you take, or 2 days before you take your final. So I'll put an announcement about that and get some of that posted, but we will cover that material in class as well. So I look forward to seeing you next week.